11.7. That's the number. Not a magnitude, not a temperature, not a death toll. 11.7, measured by an instrument buried in a hole in the ground on the island of Hawaii. And when it climbs a little higher, one of the most watched volcanoes on this planet is going to open up and throw molten rock into the sky. And here's the part that should stop you. The scientists watching that number have already told the public when it's going to happen. Not vaguely, not someday. They've published a window, a specific stretch of days on the calendar, and they've been doing this episode after episode for more than a year and a half. 53 times, Kilauea has torn open, drained itself, sealed over, and started refilling. And for most of those 53 times, somebody at the United States Geological Survey said in advance, roughly, here's when. That's not how volcanoes are supposed to work. Volcanoes are the things we don't get to predict. So what's different here? What is that number actually measuring? And why did the window for the next eruption move twice in the last week? Stay with this one, because the answer is stranger and more precise than almost anyone outside Hawaii realizes. And if you follow what this planet does day to day, this channel exists to bring you exactly this kind of thing before the news catches up. That's what the subscribe button is for. Let's start with what just ended, because you can't understand the countdown without understanding the drain. On the 12th of August, 2026, at around 3:45 in the afternoon local time, the floor of Halemaumau crater stopped pretending to be quiet. Lava fountaining began at the north vent. Over the next several hours, it built into a sustained column of molten rock reaching about 500 feet above the ground, a jet of liquid stone, roughly as tall as a 50-story office building, standing up out of a crater floor and staying up hour after hour, feeding flows across the crater bottom. The plume above it climbed to something like 18,000 feet above sea level. Think about that for a second. The top of that ash and gas column was riding higher than any mountain peak in the lower 48 states. Tephra, the glassy shrapnel these fountains manufacture, everything from coarse grit down to the fine golden filaments Hawaiians call Pele's hair, fell out of that plume and landed mostly southwest of the vents, inside the closed section of Hawaii Volcanoes National Park. It ran for 9.6 hours, a full working day of eruption plus overtime. And then, at 1:23 in the morning on the 13th of August, it stopped. Not faded, not tapered. The observatory's own language for it is that it ended abruptly. One moment there's a 500-foot fountain of molten rock, the next there isn't. That abruptness is not a detail. That abruptness is the entire mechanism, and we're coming back to it. Something else happened during episode 53 that hasn't happened before in quite this way. Behind the south vent, on the slope, the ground gave way and formed a collapse pit, and out of that pit, a brand new vent opened. The observatory calls it the west vent. It didn't fountain. What it did was quieter. And if you've ever stood near a gas flare, more unsettling. It produced overflows before the main event, and then it burned. Intermittent flames, visible through most of the eruption. Flames on a volcano surprise people. Lava doesn't burn, it's already molten rock. There's nothing left to combust. What burns is gas escaping ahead of it, igniting as it meets the air. So that new vent spent the night breathing fire, while the north vent did the fountaining, and the south vent, the one that has produced some of the tallest fountains of this entire eruption, sat completely dark and did nothing at all. 3 vents, 3 different behaviors, same crater, same night. Now, the number bolted into the ground near Uekahuna, at the summit of Kilauea, there's an instrument called a borehole tiltmeter. It sits in a shaft below the surface, and its only job is to notice when the ground it's sitting on stops being level. It reports in a unit called the microradian, and I want you to understand how ridiculous that unit is before we go any further. 1 microradian is the tilt you'd get if you took a plank a mile long, laid it flat on perfectly level ground, and then lifted one end by about the thickness of 2 credit cards stacked together. That's 1. The instrument tracks fractions of it. And here is what that absurdly sensitive device sees. When Kilauea fountains, It's emptying a reservoir of magma stored beneath the caldera. As that reservoir loses volume, it contracts, and the ground above and around it sags inward toward the summit. The tilt meter registers that as deflation. During episode 53, one summit instrument recorded about 13.9 microradians of that inward sag. Another, at a site called Summer Camp, recorded around 19.1. Then the eruption stops. And immediately, not after days, immediately magma from deeper in the system starts pushing back up into that emptied space. The reservoir swells, the ground above it bulges and tilts outward. Inflation. That switch, from sag to swell, happened within moments of episode 53 ending. The observatory has said plainly that the abruptness of that flip, combined with the glow still visible in the vents, is what tells them episode 54 is coming. But knowing it's coming isn't the impressive part. Every volcanologist alive can tell you an active volcano will erupt again. The impressive part is the date. Here's why the date works, and this is where Kilauea does something that most volcanoes on Earth flatly refuse to do. Picture the kind of rain gauge that meteorologists have used for a century. Inside it, there's a tiny seesaw with a bucket on each end. Rain drips in, one drop at a time, and nothing happens. The bucket just fills. It fills at whatever rate the rain is falling. And then, at one exact weight, not before and not after, the bucket tips. It dumps everything it's holding in a single motion, snaps back, and starts filling again. The tipping point never changes. Only the filling rate does. Kilauea, since roughly the 5th episode of this eruption, has been behaving like that bucket. The observatory noticed something that shouldn't hold but does. The amount of deflation during an episode and the amount of inflation during the following pause are nearly balanced. The volcano empties by a certain amount, refills by almost exactly that same amount, and then goes, which means the eruption isn't triggered by some mysterious hidden cue. It's triggered by pressure reaching a threshold, the same threshold, over and over. And if you know where the tipping point is, and you can measure how fast the bucket is filling, then you can do arithmetic. That's it. That's the whole forecast. Measure the rate of inflation, compare it to the target where the last episode started, divide, and you get a date range. The method belongs to Ingrid Johansson, a research geophysicist at the Hawaiian Volcano Observatory, and the observatory has been publishing these windows publicly since episode 5. Residents downwind use them to plan around Tephra Fall. The national park uses them for closures. Visitors use them to decide which night to drive up. A volcano with a published schedule. Let that idea land properly, because in the history of this science, it's close to unheard of. So where does that leave us right now, tonight? As of the most recent daily update from the observatory, the Uekahuna tilt meter had recovered about 11.7 microradians of inflation since episode 53 ended. The instrument at summer camp had logged around 15.1. Compare those to what came out 13.9 and 19.1, and you can see the bucket is most of the way full. The published window is the 22nd through the 27th of August, and if this were a clean fill, that window would be tighter than that. It isn't clean. Which brings us to the complication, and to the reason I find this story more interesting than a simple countdown. Twice during this pause, the ground has stopped rising and started sinking again. The observatory calls these deflationary steps. The first one began early on the 14th of August. The second one started around 7 in the evening on the 20th, after a full day of inflation, and it was still going the following morning. During a deflationary step, the volcano essentially pauses its own countdown. The bucket stops filling. Sometimes it even drains a little. These steps typically last 1 to 3 days. Then inflation resumes, and near the end of a pause, it usually resumes fast. But the observatory has been blunt about the limitation here, and I respect them enormously for it. The deflationary steps are not possible to forecast. They can see one once it's started, they cannot see one coming, and every time one appears, the window has to be pushed back. That's exactly what happened this week. The forecast for episode 54 has already been redrawn more than once from a window opening on the 21st out to a window that now runs through the 27th, depending entirely on when the deflation stops and the rise resumes. Which raises a question worth sitting with. If you're watching an instrument that can detect a mile-long plank tilting by the width of 2 credit cards, and you still can't see these steps coming, what's causing them? Before we get to that, tell me something in the comments, because I'm curious how many of you have actually stood near this. If you've been up to Kilauea, or you live on the Big Island, and you've watched a fountain light the underside of the clouds from your own driveway, say so. That's the audience I want to hear from on this one. Now there's a second complication, and it isn't geological at all. Hurricane Lala. The storm hit the island of Hawaii during this pause, and it did something that no volcanic model accounts for. It knocked out power across Hawaii Volcanoes National Park, including the observatory's own facilities, and as of the most recent update, that power still hadn't come back. Monitoring stations went offline. Data outages came and went. Several summit instruments remained down while crews worked to repair them and re-establish connections. And the tilt meters caught something worse than an outage. They caught the rain. This is a known problem, and it has bitten the forecast before. Back in mid-March, a series of Kona-low storms dumped enough water into the ground around the summit that the excess groundwater physically shifted the soil near the instruments. The tilt meter can't tell the difference between ground moving because magma pushed it and ground moving because water saturated it. It just reports tilt. That contamination added real uncertainty to the timing of episode 44. So picture the situation the observatory has been working in. A volcano refilling toward a threshold. An instrument network partly offline after a hurricane. Rain soaking the very ground the surviving instruments are measuring, deflationary steps arriving without warning, and a public forecast to publish anyway. And it gets 1 degree harder because the National Weather Service has flagged the possible arrival of another tropical storm system this weekend with the potential for torrential rain over the same days as the eruption window. The observatory issued a warning about that overlap in plain language. If an eruption and a storm land on top of each other, conditions could become extreme and unsuitable for viewing, and closures should be expected. A lava fountain in a downpour. That's the scenario they're preparing people for. Here's where I need to be straight with you, because there's a version of this story circulating online that is louder and wronger than what's happening. This is not an explosion. It is not a catastrophe building toward a catastrophe. Kilauea's alert level right now is advisory, and its aviation color code is yellow. The observatory generally raises those to watch and orange in the hours just before fountaining actually starts. The eruption is confined to a closed area inside Hawaii Volcanoes National Park. The crater rim around Halemaumau has been shut to the public since late 2007. Lava has not threatened surrounding communities during this eruption cycle. Nobody is being evacuated. No town is in the path. And scientists named the date is a headline, not a fact. What they named is a window 6 days wide and redrawn twice this week. That's not a prophecy. That's a rate calculation with error bars published honestly, adjusted publicly every time the volcano does something the model didn't include. I'd argue that's more impressive than certainty would be. Anyone can be confident. Publishing a number you know you'll have to correct in front of everyone, and correcting it, and explaining why that's the harder thing. There's one more piece of honesty in this that most coverage skips entirely. The observatory has said outright that this ability will end. Not might, will. The forecasts work because the volcano is currently behaving in a repeatable way, and volcanoes don't owe anyone repeatability. The day Kilauea changes its pattern and there have already been brief earthquake swarms at the summit worth keeping an eye on, the windows stop working, and the science goes back to watching and waiting like everywhere else on Earth. So what is the real hazard if it isn't lava reaching a town? It's the air. Even while this eruption is paused, with no fountain, no glow visible in daylight, nothing on the webcams but a dark crater floor, the summit is exhaling sulfur dioxide at a rate that typically runs somewhere between 1,000 and 5,000 tons a day. At the high end, that's the weight of about 2,000 pickup trucks, except you can't see it. It doesn't stay where it's produced, and it reacts in the atmosphere to make VOG, the volcanic haze that settles over downwind communities and makes people with asthma and heart conditions genuinely unwell. Right now, the winds are out of the northeast, which pushes that plume to the southwest. That's the direction the tephra went during episode 53, too, which is why the forecast window matters to real people. If you live downwind and you know a fountaining episode is likely in the next few days, you can cover the water catchment, bring in what shouldn't be sitting outside, and plan around the air. That's the actual payoff of predicting a volcano, not spectacle, laundry, water tanks, and inhalers. Now, let me widen this out, because 53 episodes is easy to say and hard to picture. This eruption started on the 23rd of December, 2024. It has been going in bursts ever since episodes that generally last less than 12 hours, separated by pauses of 2 weeks or more. But that regularity is recent. Earlier on, the volcano was far less disciplined. Episode 3 ran for 8.5 days. Episode 20 lasted 4.5 hours. The observatory's own public affairs people have said it's never been the same day twice. The fountains climbed as the eruption matured. Through the first 2 months, height stayed under about 650 feet. Then, episode 15, in late March of 2025, jumped to around 1,050 feet, and after that, the volcano seemed to find its range, repeatedly throwing lava 1,000 feet and more into the air. The record came on the 17th of October, when the south vent produced a fountain measured at about 1,574 feet. 5 statues of Liberty stacked base to torch, made of liquid rock, standing in the air on the floor of a crater, and the volume behind that is difficult to hold in your head. During one episode in June of 2025, lava came out of the north vent fast enough that the peak rate was roughly 3 backyard swimming pools of molten rock every second. In a single night, that episode resurfaced up to half the floor of Halemaumau. Episode 53, by comparison, was modest. 500 feet, 9.5 hours, one vent doing the work while another quietly caught fire, which is precisely why the next one is worth watching. A smaller episode means less magma left the chamber. Less magma out means less refilling required to get back to the tipping point, and the pause runs shorter. That relationship isn't speculation. It's the pattern the observatory has documented across this eruption, with the size of the deflation during an episode scaling to the length of the pause that follows. So the volcano is, in a sense, telling you how long you have. You just have to be able to read tilt. Here's what to watch for, specifically, because there are signals, and then there are the signals that matter. The first one is negative. The deflationary step has to end. As long as the ground keeps sinking, the window keeps sliding. The moment inflation resumes and near the end of a pause, it tends to come back sharply rather than gently. The arithmetic tightens up fast. The second is the vents themselves. Right now, the north vent is showing continuous moderate to strong glow overnight. The west vent is showing weak and intermittent glow, and the south vent has stayed dark. Strengthening glow means magma is sitting close to the surface. If those overnight webcam views brighten across multiple vents, the system is loading. The third is precursory overflow. Before recent episodes, the vents have spilled small amounts of lava onto the crater floor in the hours beforehand, the pressure finding the door before it kicks it open. And the fourth is administrative, but it's the clearest tell of all, the alert level. When the observatory moves Kilauea from advisory to watch and the aviation code from yellow to orange, that is the institutional way of saying this is now hours away, not days. Beneath all of that, the summit murmurs continuously. Low-level seismic tremor with occasional ragged spikes has been running through most of every recent day, and the summit region logged about 8 small earthquakes in a single 24-hour period. That's not a swarm. That's a machine idling. Somewhere in the next several days, if the pattern holds, that idle becomes a roar. The north vent will spatter, then jet, then build. The plume will go up. A crater that's been dark for 2 weeks will light the clouds above the Big Island bright enough to see from miles away, and a live stream audience scattered across every time zone on Earth will watch it happen in real time on a camera bolted to a rock. And an instrument in a hole in the ground will register a sudden, decisive tilt in the other direction, the bucket tipping, dumping, snapping back, and the count to episode 55 will begin at 0. The window is open now and runs through the 27th of August, weather and deflationary steps permitting. If the storm arrives on schedule, it may run through rain. We'll be covering it the moment fountaining begins, along with whatever else this planet decides to do in the meantime. So if you want that in your feed the day it lands rather than a week later, the bell is the part that matters, not just the subscribe. Watch the tilt. It's already moving.